factoring review for this section, the biggest thing to remember is you have to remember your factoring tree. And what I mean by that is the first thing we always start with is GCF. You always want to see if you can GCF things to make your life easier. Okay? So for example, this one's all we can do is GCF. So you kind of look at the numbers. What the numbers have in common? They have the 15. Okay? The x squared and the x has an x in common. Y cubed and y squared is a y squared in common. Z4 and z squared. So that's what you can pull out. How do I know which exponents I take out? You always can take out the smallest one in terms of degree. Okay, so if it's got a y4 and a y6, you can take the y4 out. So now we go ahead and divide this. When you're pulling stuff out, that act is division. Let's make sure we remember that. So 15 came out, so it's gone in terms of being gone. It has a 1. X squared, we took 1x out. We have 1x left. Y cubed, we took 2 of the y's out. We have a y left. Z4, we took 2 of them out. We have 2 left. 45 divided by 15 is 3. We took an x out, we took a y2 out, we took a z2 out. That's it. That's all that's left there. So that's all you can do. That's just a GCF factoring. Okay. You know the difference of squares, okay? It's the same thing, just has to understand the differences in what's going on. In terms of, we got 36, that's a perfect square, x squared is a perfect square, y squared is a perfect square, 4 is a perfect square, z squared is a perfect square. So they're all perfect squares, so it works for difference of squares. So it's simply going to be, square root of 36 is 6x, y, minus 2, z, 6x, y, plus 2z. Okay. So when you're looking at ones like C, before we have to get into the factor theorem or go into long division, okay, or synthetic division, we're going to try to do it by grouping first. Grouping's the easy one. That's where you just group and you just GCF and see if you can get them to match. In this case, I pull out an x squared. I get x minus 1. Here I'd pull out a negative 4. I get x minus 1. These match, so I'm happy because that is the factor. So you get x squared minus 4 times x minus 1. I'll slow down here a bit. But that x squared minus 4 is a difference of squares, so I can go again. Like so. Whoops, I had minus 1. There's your factors for that one. A couple quick ways you can check that if you're not sure if it's right or not is that no matter what, these three are going to hit. X times x times x. That's going to be your highest degree. Well, that's just x cubed. What's the one in the front? X cubed. 2 times negative 2 is negative 4 times a negative 1 is a positive 4. I have a positive 4 in the end. So you can kind of check the ends to make sure they match up. Okay? Any questions there? Okay, D, can't factor it. I won't waste your time. It's not factorable. You could solve it if you wanted to, set equal to 0 type of deal, but it's not factorable. Okay, this one's in your book. I'm not sure. I don't think you guys have done difference of cubes or products of cubes, but in your book, there's like page 2. There's just a formula thing there. You don't have to memorize that, but the pattern goes like this for these guys. So see how 8's a perfect cube, right? So A cubed is perfect cube, 27 is perfect cube, and so is B cubed. So that falls into your difference of cubes or a product of cubes, or excuse me, sum of cubes. Difference cube and sum of cubes. There's just 2 formulas. The difference of cubes, what it does is it just does this. So like that. And so what it does is it's the cube root is 2. The cube root is 3. The cube root of a cubed is a. Cube root of that is b. And then it's the square of it. Okay, so we know that that squared is 4a squared. This squared is 9b squared. And then these multiplied, 2 times 3 is 6ab. So that's what the formula says on it. Like, you can look at it. I'll show it to you tomorrow. But just getting you familiar with looking at difference of cubes in terms of it's essentially a formula just like difference of squares is. Just wanted you to see it. Okay. This one's just inspection. Factors of 18 that are 3 apart. Hopefully we're not too rusty. That's simply x minus 6, x plus 3. Negative 6 times 3 is negative 18. Negative 6 plus 3 is negative 3. Okay, any questions on the factoring stuff yet? All right. Okay, G is the one we don't like to do too much, the decomp. Okay, we have to go, we can't pull anything out. 5, 20, and 4 have nothing in common. 25 times 4 is 100. Factors 100 that are 20 apart. That'd be 10 and 10, yeah, say the easy ones there. So negative 10, negative 10. So then we'd go 25x squared minus 10x. Remember, decomp, you're taking the 20, breaking it into 2 factors so that you can have factor by grouping, like here on C. Minus 10x plus 4. Group. 5x comes out. 5x minus 2. Negative 2 comes out. 5x minus 2. And you see it's 5x minus 2 squared. There's 2 of them. So you're here. Okay, I forget in 30, since there's the only one I haven't taught the complete class, I've only tutored it quite a bit, but do you guys factor those ones, the cubics like that? Did you guys break those down and factor them? So what strategies would you guys use to factor h? Did you use the factor theorem? Okay, so when I say that, you know what I'm talking about? Okay, so the factor theorem, if you're rusty from 30, okay, means you think about all the factors of 3. So it's nice this is not very many, it's just 1 and 3, okay? So what this means, okay, is that because the end here is a number 3, my factors can only be a combination of these 4 numbers. It's going to be, it's cubic, so it's going to be 3 of them. Okay, but that's all it can be. They can be repeated, okay, but that's your only option. So you do have a little bit of guessing game to kind of like figure out like which one do I want to try, and then you just do a synthetic division and you kind of test out to see if it works. I tried, for example, I tried 1 the first time, positive 1, and it didn't work, but then negative 1 did work. If negative 1 works, though, what's the factor? Positive 1. It's going to be, if negative 1 works, that's you're testing the 0. Okay, don't forget that. You're testing the 0. So what I'm talking about is this. The 0 of this is negative 1, so I don't know if you did it this way, but you have your synthetic division. You got 2, negative 5, negative 4, and 3. This is very quick. It's very helpful. Okay, so the 2 drops down. That's how you start it. Everybody okay with that? You times these. Okay, then you add, yep. Times them again. Add. Times them again. Add. By that ending in 0, that means it is a factor of that given expression. Okay, let's just pause a second. Don't let me mow you over if I lost you, if you forgot this stuff. The 2, negative 5, negative 4, and 3 just came from here. 2, negative 5, negative 4, and 3. Just drop them right down. Okay, to start this method, you drop the first one and then multiply, put it there, add. Multiply, put it there, add. Multiply, put it there, add. That's all it is. Okay? So what you've done is x plus 1 is a factor. Now we have this into a quadratic. We should be very comfortable in this state with factoring it. So that means this right here is 2x squared minus 7x plus 3. And we need to factor that now. So we'll just use decomp. 2 times 3, we get 6. Factor of 6 equals negative 7 is negative 6 and negative 1. Group. Plot of 2x. Plot of negative 1. So here you go. So we have negative 1, 1/2, and 3 are the zeros. Okay? But then again, you can test this. Look, x times 2x times x. It's 2x cubed. 1 times negative 1 is a negative 1 times a negative 3 is a positive 3. So we feel good about our answer right now. The ends match up. Any questions on the factoring before we go into rationalizing? Easy peasy. Okay. All right, so these ones, the first ones are actually probably the most difficult, the common denominator stuff. So in order to get a common denominator, you make the bottoms the same, and it just gives you ugly stuff of doing that. So remember, if you want to make the bottoms the same and they're not relatable at all, you're going to times them by each other. So I'm going to times this by 3, root x, root x. So you're going to get root x over 3, 3 root x, plus 3 over 3 root x. Okay, and so then we're simply going to have, so 3 plus root x over 3 root x. So now, if we want to make sure we rationalize, we're practicing that anyways, we don't want root x in the bottom, so we have to go ahead and do this really quickly. So then our final answer, simplest answer, would be that. 3 root x plus x over 3x. Okay, for B, we're going to kind of take this as separate problems, but luckily for us, we just did that problem. Okay, so we can just steal our answer from here, place it there. So we go 3 root x plus x over 3x. So I just took this answer and I put it on the top there, is all over x minus 9. So where does the x minus 9 go? Well, it's division, right? X minus 9 is over 1. So remember, underachiever, overachiever. Remember I used to tell you that every now and then we were doing stuff with rational expressions. So the x minus 9 just slides to the bottom. So you're going to have simply 3 root x plus x over 3x times x minus 9. And that's all. Okay, this last one for common denominator, you can see this one has a 3, that's a 4, so it needs one more. So we simply just need to multiply 4x minus 1 to the top and bottom just to this one. This guy just stays the same. Then we have to distribute the top. So the top's going to be for here 24x minus 6 plus the x. 25x minus the 6 over 4x minus 1 to the 4th. I just didn't write it's under here. It's common denominator, we already got it the same, so. Okay. 2 rationalize the denominator, then we're going to do 2 rationalize the numerator and call it good for today. Okay, so root 2 is the problem. Root 2 tops and bottom. That's going to be 2 times 3 is 6, so root 2 over 6. Okay, second one, we have to use conjugate. We have a radical in a binomial form, so we have to use the conjugate to get rid of it. So I have to go root x plus 1 minus 3 to top and bottom. Okay, the bottom's the easy one. I don't have to waste my time at the middle. We understand how the conjugate works. We're going to have x plus 1 minus 9. This times this is x plus 1. Negative 3 times 3 is minus 9. Let's leave that there for a second. The other piece isn't too bad because the top's just a monomial, so it's kind of simple. The x just hits these two. So it's simply going to be x times x plus 1 minus 3x. And then just combine like terms in the bottom and we're done. So x so that would be your simplified expression there. Okay. X times x plus 1, x times root x plus 1 minus 3x over x minus 8. All right, two more. So now, just for practice, they want us to rationalize the numerator. So they want the numerator not to have any radicals. Okay, so same game. We're just doing it opposite direction. That's it. 3x over 5 root x. Just asking us to do it the opposite direction. Okay, and lastly, b, I got to use the conjugate because it's a binomial. Again, it's nice. I'm going to use the monomial on the bottom there, so it's not that hard. So the top's simply going to be x plus 4 minus 4, which is also nice because the 4's cancel. So top is simply going to be x. The bottom is going to be x root x plus 4 plus 2x. And that's as far as you can go. Okay, so that concludes our pre-calc review. So we'll stop there.